Hi students, this is Alex here. In this video, we are going to find the area of the smaller part of the circle whose equation is x square plus y square is equal to a square, which is cut off by the line x is equal to a by root 2. From the circle equation, we can know the center is origin and the radius is a. So we can take the x-axis and y-axis and draw the circle with center origin and the radius a. And a by root 2 is a constant which is less than a. After drawing the circle, let's mark the origin 0, 0 and the radius is here. This length is a. So this point is a, 0. A by root 2 is a constant which is less than a. And when x is equal to a by root 2, it is a vertical line passing through a by root 2 on the value of x. So this point is a by root 2, 0. Now we have to find the smaller part of the circle which is cut off by this line. So this is the region. But we can find the area present in the first quadrant and we can take twice of that. And the curve equation is nothing but the circle equation. The value of y from here is y equal to root of a square minus x square. Now coming to the area, we have above x-axis and below x-axis which is symmetrical, so we have to take twice to find the complete area, and the limit is starting from a by root 2 and till it is a. This is our limit. So we take a by root 2 till a and it is y dx. Now we are going to substitute y. So 2 integral a by root 2 till a, and this is root of a square minus x square dx. Now we are going to use the integration formula, which is integral root of a square minus x square dx equal to x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. Now coming to this integration, we have 2 outside. When we integrate this, we have to write the full formula x by 2 root of a square minus x square plus a square by 2 sine inverse x by a, and our limit is from a by root 2 till a. Now we are going to substitute the upper limit. So we take this 2. When we substitute the upper limit, when I put a here, a square minus a square is 0. So the first term is 0. And second term is a square by 2 into sine inverse x by a. So we have to put a in place of x. So a by a. And minus, when I put lower limit, this x is replaced with a by root 2. And already there is a 2 in the denominator. So a by 2 root 2. Then root of a square minus a by root 2 whole square. Then plus a square by 2 sine inverse a by root 2, and there is a in the denominator also. Then bracket close. Now further simplifying this, still we have 2 outside and this is a square by 2. After cancelling this, sine inverse 1. So we take sine inverse 1 as it is. Then minus open bracket a by 2 root 2, and this is root of a square minus a square by 2 plus a square by 2 sine inverse. After cancelling this a and a, we get 1 by root 2, which is inside the sine inverse, bracket close, and the full bracket close. Now this is 2. Now this is a square by 2 sine inverse 1 is pi by 2 minus bracket open a by 2 root 2. Here a square minus a square by 2 is a square by 2 after taking LCM. So I put that inside the root plus a square by 2, and sin inverse 1 by root 2 is pi by 4. Bracket close, and we close this. Now this is 2 and a square pi by 4 minus this is a by 2 root 2, and this will be a by root 2 by taking the root separately to the numerator and denominator, and the last term is a square pi by 8. Bracket close. Now we write only this 2, and this is pi a square by 4. Taking the minus sign inside, this is a square divided by combining these two, root 2, root into root is 2, and there is one more 2, so it is 4. Then minus, this minus taken inside. Now this is pi a square by 8. We are going to take LCM for the entire term. So we have 2 outside, then the LCM is 8. So this will become 2 pi a square, and this becomes 2 a square, and this becomes pi a square. We can combine these two terms, that is 2 pi a square minus pi a square is pi a square, and we can cancel this. So pi a square minus 2 a square whole divided by 4. Actually, we can take a square by 4 common, so the remaining will be pi minus 2. In the textbook, they have taken a square by 2 common, so if that is the case, we will be having a square by 2, and one more 2 is remaining, that is taken along with this term, and dividing each term individually, so we get a square by 2 into pi by 2 minus 1. So we can leave the answer in any form. So the required area is a square by 2 into pi by 2 minus 1 square units.